In this video, I aim to solve a leftover problem from the previous video. I will still use the property chain support for this subject, which I am showing here, but the listeners will no longer implement the interface. Instead, I will use lambda expressions. The problem I'm trying to solve is present in the sensor log class. Because of the listener interface, all events end up in the same method, here. Handling new events requires me to update this method. I will just remove the method and remove the implements declaration at the top. So that's what I want to change. But first, I just want to go over how we move from interface implementation to lambda expression, a bit of history or evolution perhaps. I will use an unrelated, very simple example. Here is a test class with a main method. Down here in the same file, I will just create a simple interface, call it printer. It will get a single method called print. The method takes a string to be printed. And that's the starting point. So the interface is abstract. And up here in the main method, I can declare a variable of type printer, but I cannot assign the variable to a new instance of the interface. That makes sense, I hope, because what would calling the print method do? That's not defined anywhere. I have no implementation of the method. So what we often do is create a new class, also just down here, adding to my mess, and it implements my interface, overrides the method, and just prints out the argument. Simple enough. In the main method, I can then instantiate the class and use it to print something out. I trust you are familiar with interfaces and that there are no surprises here. Now the next step. Instead of having to create a new class and implement the interface, as I did down below, I can actually create a new instance of the interface. Yes, I just said that was not possible. Yes, I lied. Let me declare a new variable, printer2. I assign it to a new instance of the interface, but the method's functionality is still not defined. So I must create an anonymous implementation, like this with the braces. And here I can override the method and print something out, just like before. So I don't have a class as such, but I do provide an implementation for the interface. It is an anonymous implementation. This is reasonably fine if you only need this anonymous class one place. A long time ago, I did this a lot for button actions in Java UI. Those actions were never shared. But I don't think this specific approach is used that much anymore, though, because there are newer ways to do things. And that leads me to the next step of the evolution, the lambda expression, which requires a small piece of background information. In Java, an interface with a single method, like the one I defined below, is what we call a functional interface. Java has a few existing already, like runnable, consumer, predicate, supplier, and probably more. And when we have a functional interface, we can create an anonymous implementation using a lambda expression instead of the anonymous class approach. So I can create a new variable with the type of my interface, like before, and assign it to be a lambda expression. First, I must declare the parameter name. The type is string because that's defined in the interface, so that is inferred here. Then the lambda arrow, a dash and a chevron, and then the method body, containing the functionality. And if the method body is just a single statement, I can remove the braces. So that's the introduction. Now let's use these lambdas for my weather sensor example. It's all sort of the same, just different syntax. It's sugar upon sugar. I think there is still an anonymous class behind this lambda expression, though I'm not too certain on the details about how Java works under the hood. So back to the weather sensor example, and let's apply this new approach. I will just show the weather sensor first. We have the property chain support here, as usual. And in each of the methods for updating the data, the support is used to notify potential listeners about the new data. I don't need to change this, I just wanted to remind you of the setup. We reused this from the previous video. Now let me find the sensor log class. It does not implement the interface this time, and I don't need to change this class. I do not need to explicitly make it a listener, as we have done earlier. I just need to tie things together, and as usual, that happens in the start method. Let's first make sure the sensor logs method log temperature is called when the weather sensor notifies. In the previous video, I would add a new listener to the subject, and I would pass in a class implementing the property change listener interface. But because that interface has a single method, it is therefore a functional interface, and I can pass in a lambda expression instead. So I create a lambda expression here. I define a variable of type property change listener, and I will assign it to a lambda expression. The argument first is a property change event, then the lambda operator, and the action to be executed. I want to retrieve the new value from the event, and then pass that into the sensor logs log temperature method, like this. Okay, instead of 2 lines requiring me to add the braces here, let me just inline the event's new value, like this. Now I can add my property change listener object to the weather sensor, making it react to the temperature event. And once again, let me clean this up by inlining the lambda expression instead of declaring an explicit variable. This simplifies my code a little bit, I think. Now, whenever the weather sensor notifies about a new temperature, the log temperature method of the sensor log is called by this lambda expression. I just need to make sure the other methods are called as well. First, the log humidity in a very similar manner, and quickly the last 2 methods as well, log wind direction and log wind speed. I could of course do the same for the other listeners, wrapping their specific methods in a lambda expression and adding that as a listener to the subject. And then the test, running the program, I get the temperature update, and there's the alert, and let's check the log. Seems good. So that's it. I have swapped out the listener interface for a lambda expression instead. I no longer have that one method which deals with everything. This seems to be a bit more flexible, I think. I can add new methods to react to the events without modifying the existing ones. The next video I plan on doing, maybe if I get to it, will expand on the lambda approach by removing the property change support. For now, thanks for watching.